Hello everyone. Today we are going to talk about something super important in computer architecture. The buses. No, not the ones you take to school, but the ones inside your computer that help different components communicate with each other. So what exactly is a bus? Think of it like a highway that connects your CPU, memory and input-output devices. Instead of each component having its own separate connection, a bus allows them to share a common pathway, making communication more efficient. Every bus has three main parts that makes communication smoother. They are data bus, address bus, and control bus. This image clearly explains the components of a system bus, which facilitates communication between the CPU, memory, and I/O devices. The system bus is nothing but the combined structure of a bus. Now, data bus. This is like the package carrier. It transfers actual data between components. And guess what? It is bidirectional, meaning data can flow both ways from the CPU to memory or from the memory to the CPU. In simple, we can say that data bus is the data what is transferred. Next, address bus. This one works like an address label. It tells the computer where the data needs to go. Unlike the data bus, this is unidirectional, meaning it only sends addresses from the processor to the memory. In simple, we can say that address bus defines where the data goes. And next, control bus. This is like the traffic controller. It ensures everything happens at the right time. It carries control signals that tells components how the operations should be performed. This one is bidirectional because both the CPU and memory need to send signals back and forth. In simple, we can say that control bus defines how it works. The next we going is how these buses are arranged in a computer. There are two ways to connect different parts inside the computer together. One, single bus structure. This is like having just one road that all traffic must use. It is simple and cost effective, but it can be slow when multiple components try to use it at the same time. Imagine a one lane road with heavy traffic, it gets congested. Now, look on the diagram of single bus. This clearly represents the structure of a single bus architecture where all the major components like processor, memory, input and output devices are connected through a single communication bus. Now, the multi-bus. This is an upgrade. It's like having separate routes, one for fetching instructions and another for fetching data. This means faster processing and less congestion. In this image, you can clearly see the structure of multi-bus architecture in which different buses handle different types of communication. In simple, we can say that single bus is one lane with more traffic, while the multi-bus is multiple lanes and faster. Now, let's see how a bus actually works. There are three main operations that are performed by the bus. First, read operation. This is when the CPU retrieves data from memory or an input device. The processor sends an address and the requested data is sent back through the data bus. The next operation is write operation. This happens when the CPU stores data in memory or sends it to an output device. The data is placed on the data bus and the CPU tells the system where to store it. And next, input output operation. This one is all about communication between the CPU and the input output devices like keyboards, mic, and printer. The control bus decides if the CPU is reading from or writing to the device. Next, we move on to the advantages. Why do we need buses? As it is simple and cost effective. Buses are easy to implement and do not require too many extra wires. The second reason is easy to install and expand. This need to add a new device, just connect it to the bus. And the third reason is it is flexible. Components can be placed anywhere along the bus as it is flexible. And the next reason is efficient data transfer. Informations can move quickly between the components. And the last reason is low maintenance. Because of their simple design, buses don't require much upkeep. These are the advantages which make us to use the buses. But of course, buses are not perfect. There are some disadvantages. One thing is single point of failure. If the bus gets damaged, the whole system can crash, which makes a lots of damage. Next, limited scalability. The more devices connected, the slower the bus becomes due to congestion. Next, difficult in troubleshooting. If something goes wrong, it can be hard to pinpoint the issue. Next, susceptible to interference. The electrical noise can mess up data transmission. And the next disadvantage is data traffic and congestion. Since all devices share the same bus, high traffic can slow things down. So, to sum it all up, buses are the backbone of communication inside a computer. They connect the CPU, memory, and other devices, making sure everything runs smoothly. Today is all about this. Hope you found this helpful. Thank you.